This is the key to topic 14, worksheet 3. And number 1, it says, for the following graph of g of x, answer the items that follow. If any of the answers is none, just say none in the blank. Okay, so notice in part A, you want to find the domain and range. So remember, the domain is a set of x coordinates. And I want you to notice that on one side, you have an arrow. On one end, the end behavior here is an arrow pointing up. And this is a closed circle. So when we talk about domain, we talk about from along the x-axis, going along the x-axis from left to right, just like this. So notice that this arrow keeps going like this. So I'm going from the idea of infinity. So I'm going from infinity all the way, any real number of x, so any real number of x from negative infinity, any real number now. So think of decimals, think of fractions, things like that, irrational numbers, rational numbers. And then I stop here, and that's that y value of 9 with a bracket. See, that's a closed circle. So you can go from parentheses negative infinity to 9 with a bracket. The range is a set of y coordinates. Note that the lowest point I touch is here. So that's that, see right here. So that's that y value negative 5. So that's bracket negative 5, comma, and then be careful. Some students are going to say this is the highest y value, but you know it's not. That's not the highest because this arrow. So you keep on going up. So I'm actually going from negative 5 all the way to infinity. So bracket negative 5 to infinity. Part B, they're asking you where it's increasing, decreasing, or constant. So that's where you may, again, want to use a color. So, and you always go, remember the interval that goes here are the x values. So you want to know the interval where the function is increasing, decreasing, constant. So where the y value is increasing, where my y values are decreasing, and where my y values are constant. So notice as I go from left to right, you're going along your domain, along the x-axis, and you always read a graph from left to right. As I go from left to right, my y values are decreasing. See that? You're decreasing, you're going down. Then all of a sudden, right here, I'm going to kind of notate that here. So right here is where they start increasing. So I'm going from decrease, from negative infinity, from negative infinity, from negative infinity all the way to, that's negative 6 here, to negative 6, I'm decreasing. And then from negative 6, see my y values are increasing. So I'm increasing all the way to this x coordinate right here, and that is negative 2. Oops, negative 2. So I'm increasing. So I'm increasing from negative 6 all the way to negative 2. Then from negative 2, notice what's happening as I go along the x-axis from negative 2, my y values are decreasing. Now they're decreasing, decreasing up to that point here, and that's the x-coordinate of 6. So from negative 2 to 6, my y values are decreasing. And then from 6 to this y value, and that's where it stops. There are no arrows here. That's where it stops. My y values are increasing. Okay, so let's answer the question. So where is it increasing? It's increasing two places, two intervals. So you're going to say, and remember when you talk about increasing, decreasing, and constant, you always use parentheses, use intervals, use parentheses. You use brackets when we're talking about domain and range. Okay, so I'm going from negative 6, comma, to negative 2, and also from 6 to 9. Okay? I am decreasing in two places from negative infinity. So that's an arrow. So from negative infinity all the way to negative 6. So negative infinity, negative 6, and also from negative 2 to positive 6. So from negative 2 to positive 6, my y values are decreasing. So negative 2, positive 6. Constant, nowhere. Okay? And if you put the word none, that's fine. Nowhere, none, you can say that as well. Okay, now let's look at C. Indicate the values of x for which g has a local maximum. Okay, so I want you to notice, remember local maximum is where you go from increase to decrease. So there's one here. So that is the point negative 2, 4, negative 2, 4, is a local max. And then now I want you to notice, see this right here? Some textbooks consider this a local max as well, so that'll be fine. So if you put that, that's fine as well. So that's the point 9, -1. So that's a local max. All right. Now, so indicate the values of x for which g has a local max. So x would be -2 and +9. So -2, 9. Okay. All right. Now over here, the local, and then the local maximum always are y equals. So what are the local max? What's the y value? Will be 4 and -1. So that's your y values, 4, -1. Don't put parentheses. If you put parentheses, that means you're indicating there's a point. So just leave it without parentheses. This is all you do. Now they're asking for a local minimum. So local minimum is where you go from decrease to increase. Okay? And so we have one here. So that's, if I label those points, that is the point 6, -6, -3. That's a local min. You also have one here, decrease, increase. So that's the point, though. That's the point 6, -5. That's also a local min. Okay? So 6, -5. So now they're asking what are those x values? So the x values are -6 and +6. So -6, +6. And then they're asking what's the, when asked for the local minimum means plural, by the way. Maxima means plural. So what are the local minimum? So there are two of them. The two y values are -3 and -5. So -3, -5. Okay? All right, now in 2 and 3, you're given functions and you're asked to evaluate those at variable expressions. So you notice it didn't say any works required. So no works required, you just need the answer. So now you in your mind though, you have to, or on a piece of paper, you do have to do something. It's just, I'm not asking for the work for these. So for 2, you have that h of x is the absolute value of 2x minus 3 divided by x plus 4. And so in 2a, you want to find h of, you want to find h of 3. So remember, h of 3 means wherever you see the variable x, you substitute 3. Now remember, that's absolute value here, so be careful in the numerator. So that's 2 times 3 minus 3 divided by 3 plus 4 is the denominator. So 2 times 3 is 6. So that's absolute value of 6 minus 3 divided by 3 plus 4 is 7. 6 minus 3 is 3, so that's absolute value of 3 divided by 7. Now get rid of the absolute value bars. So the absolute value of 3 is a positive 3 sevenths. So your answer is 3 sevenths. So in 2a, the answer is 3 sevenths. Okay, let's talk about B. Now, hopefully you looked at the example similar to that we did in lesson or on a worksheet, just like it. So h of x plus 5 means that where we see the variable x, you substitute x plus 5. That's what that means. So this becomes the absolute value of 2 times x plus 5. So in place of x, you substitute x plus 5. So 2x plus 5. Minus 3 divided by, in place of x, you substitute x plus 5. So x plus 5 plus 4. Okay, now this is where you have to be careful. So let's go ahead and distribute here. So I do expect you to go further with the numerator. So you get 2x plus 10, 2 times 5 is 10, minus 3, divided by, and this becomes x plus 9. 5 plus 4 is 9. Okay, now the numerator, remember I'm still putting absolute value bars. You get 2x, 10 subtract 3 is 7. So that's 2x plus 7 divided by x plus 9. Now here's where you got to remember. You see, you still have a variable expression, right? See here, this was a constant. This was a real number that you substituted. You all know what the absolute value of 3 is. There's no confusion there. The absolute value of 3 is a positive 3. See, this is a variable expression. You don't know whether x is positive or negative. So you have to leave within the absolute value bars. You can't change it. And so that's the answer. That's the answer. You just leave it like that. All right, so h of x plus 5 will be, and that's not an easy one. Students get confused with absolute value bars. They don't know whether to leave it off or keep it. You're going to keep it. I would keep it if the variable expression is still there, because you don't know whether x is positive or negative. If you leave it off, it's not correct. Okay, be careful. So you must keep it. So it's the absolute value of 2x plus 7 divided by x plus 9. Okay, let's look at 3. So in 3, you have a linear function. So f of x is negative 4x plus 3. And you're asked to find a, which you want to find f of negative x. So in place of x, you're going to substitute negative x. That's what that says. So this becomes negative 4 times, in place of x, I substitute negative x. So x becomes negative x plus 3. You are expected to go further with this. A negative 4 times a negative x is a positive 4x plus 3. So the answer is 4x plus 3. So 3a, the answer is 4x plus 3. Okay, b, now you want to find x minus 2, f of x minus 2. So b, f of x minus 2. So again, in place of x, you're going to substitute x minus 2. So this becomes negative 4 times, in place of x, put x minus 2 in parentheses, and then plus 3. Now go ahead and distribute. I get negative 4 times x is negative 4x. Negative 4 times a negative 2 is a positive 8 plus 3. You are expected to simplify this, so this becomes negative 4x plus 11. So f of x minus 2 is equal to negative 4x plus 11. Okay, so that's going to take care of the worksheet 3 for topic 14.